So we check for log of numbers, 84 under 0. 84 under 0 will give us 9243. 9243 minus 3, which is the same thing as saying minus 3 plus 0.9243, which is the same thing as minus 3.9243, and that is what is known as bar 3.9243. The second question, which is 0.6504. To start from, you have this, just one, so you have 6.504 times 10 raised to the power minus 1. So log of 6.504 times 10 raised to the power minus 1. Applying the law of logarithm, just like the case shown above, then we have this plus log 10 raised to the power minus 1. So this one is log 6.504, and this one will become log of the same base is 1, so that becomes plus minus 1, so which is now log 6.504 minus 1. So we check for 65 under 0, difference 4. So we go to logarithm of number 65 under 0. 65 under 0 is 8129, difference 4. 3. So 3 plus 8129, that becomes 8132. So we have 0.8132 minus 1, which can be written as minus 1 plus 0.8132. And that gives us minus 1.8132, which is the same thing as about 1.8132. So this is the answer for the B case. Use anti-log tables to find the numbers whose logarithm are this: minus 5.8226 and minus 2.5008. The first one is minus 5.8226. A. B. Minus 2.5008. We have to use anti-log table to look for this. So automatically, by so doing, we have 10 minus 5.82. Anti-log, we are trying to look for anti-log, and this can be expressed as 10 raised to the power minus 5 times 10 raised to the power 0.8226. So now we check for the anti-log of this value. So under the anti-log, we have anti-log of numbers 82 under 2. 82 under 2, difference 6. 82 under 2. That's 6637. 6637, difference 6. And 6 is 9. So we have 9. So we add it. So we have 6, 1, 4, 6, 6. And since it's 0 point, it will be 0.1. So times 10 raised to the power minus 5. So automatically this one becomes 6.646 times 10 raised to the power minus 5. So this is the value. This is the answer for this, or the anti-log of this. So the second case, we use the same method. So we have minus 2.5008. So which can be expressed as 10 raised to the power minus 2.5008, which can be simplified as 10 raised to the power minus 2 times 10 raised to the power 0.5008. So we look for the antilog of this, which is 50 under 0. 50 under 0 is 3162. 50 under 0. 3162. Difference 8. Difference 8. Antilog of numbers. Difference 8. Difference 8 is 6. So we add 6 to this. So by adding 6 to this, we have 8, 6, 3, 1. So since you have it to 0.1, so times 10 power minus 2. So eventually you have 3.168 times 10 power minus 2. And this is the antilog of this value. This is the antilog of this first one, and this one is the antilog of this second value. A 0.085 raised to power 3 can be resolved into log reading this way. So you have 0.085 raised to power 3, which is bar 2.9294 when it is resolved using the 4-figure table, checking for logarithm of this value. Then raised to power 3, you multiply by 3 and you have this. So we go to our antilog of numbers and check for 78. Antilog of numbers, we check for 78. Antilog of numbers, 78 under 8. Under 8, 78 under 8. 6138. We have 6138. Difference 2. Difference 2. Difference 2 is 3. So we add 3 to this. So we have 1, 4, 1, 6. And since we have it to the power 4, so automatically it will be 0.0006141. So this is the answer to this question. So the answer to the question is 0.0006141. Question B, which asks fourth root of 0.00075. So we have number log reading. So here we have 0.00075, which gives us bar 4. So we check for logarithm of number 75 under 0. Go to logarithm of numbers. 75 under 0, that's 8751. 8751. So divided by 4. So by dividing this by 4, we have about 1.2. We have 1, 8, 32, remember, that's 7. So approximately 8. So we have bar 1.2188. So we go to antilog of numbers and we check for 21. 21 under 8. 21 under 8. 1652. Difference 8. Sequences and series. What is meant by sequence? A sequence is a set of terms arranged according to a rule, while a series is obtained by adding together the terms of a sequence. It may be finite or infinite. When I say finite, I mean it ends, that is, it terminates, while infinite means it is unending or it does not terminate. Example 1. Find the number of terms in each of the following set of numbers. A, you have 1, 5, 9, 13, 17. B, you have 2, 6, 18, 54, comma 162, comma dash dash dash. So these are the questions that are taken as example. Then the C part is 10, 9, 7, 4, 0, minus 5, minus 11. So these are the questions. Question asks A, B, and C. And the question asks us to find the number of terms in each of the following sets of numbers. So if you are to look for the 3 consecutive terms here, we've studied the pattern so that we can deduce what would be the trend. If you look at the first question, which is A part, the first number here, or the first term here, is 5. The first term here is 1, while the second term is 5. The third term is 9, while the fourth term is 13. If you look at this closely, it is the difference between the first and the second term is 4. The difference between the second and the third term is also 4, while the difference between the third term and the fourth term is also 4. So it means that